Hello, and welcome to another edition of Cracking the Cryptic, where today we're asking the question, can a Sudoku be beautiful? And by beautiful, I don't just mean the colours that I've highlighted this killer Sudoku in, but I mean in terms of its logic. And this puzzle is by Serkan Yürekli. We've done one of his killer Sudokus before, which is sort of partial killer Sudokus. You can see that not all of the grid contains a cage. And I tried to show this on the computer, but it just seemed very unclear. So what I'm going to try and do today is to solve the puzzle on paper for a change and talk you through some of the logic. Now I'm hoping that what we'll find as we go through is that this is indeed another example of a beautiful puzzle. So how would I approach it? Well, firstly, I would notice that there are some cells where we can at least write some possibilities in immediately. So the 16 cage here in 2, that has to be a 7 and a 9 in some order. Now, I'm hoping again that you can see the annotations I'm making there. I have my own way of doing this, so you'll see how I solve in practice here, whereas usually obviously I've been on the computer solving and forced to use the computer notation. So this 9 in this column here, in column 6, means that there has to be a 9 here, because a 23 cage has got to contain a 6, 8 and a 9, and that allows me to write a 6 and an 8 into these two positions like this. Now what else can we see? Okay, yes, so this 22 cage here, a 22 cage must also always contain a 9. So we can write the 9 into this position, like that. And that means that this square here actually contains the 9 in the 16 box. So that's 9 and that's 7. And then as there is a 7 in this 3x3 cage here, the version of the 22 cage that this needs to be is going to be 958. It can't be 967 because of this 7. So that means that we're going to have a 5 and an 8 in some order here. Okay, so what would I now want to look for in order to make more progress? Let's see. Okay, right, well we have a 9 here and a 9 here. Therefore the 9 in this 3x3 box here needs to be in the bottom row. But we can see we have this huge 18 cage that sort of spans some of this 3x3 box. But if we were to put a 9 somewhere in this 18 cage, it couldn't be filled, because if we put a 9 here, for example, the other 4 numbers in the 18 cage would have to add up to 9 in order to make the cage add up to 18. But the smallest number that 4 numbers can add up to, if they're distinct, is 10. 1, 2, 3 and 4. They sum to 10. So the 9 is going to have to be in this square here. Okay. Okay, so what now? I suppose I would fill in a 1, 2, 4 over here in the 7 cage. And that's interesting, because we look at the interaction between this 7 cage here and this 5 cage. If this 5 cage is a 1 and a 4, this 7 cage could not be filled, because these two cells, one of them could be a 2 obviously, but the other would have to be a 1 or a 4, so there would then be 3 1s and 4s in this 3x3 box. So this 5 cage is not 1 and 4, therefore it has to be 2 and 3 in some order, and that means that this cell must be a 2, which means this cell must be a 2, which means this cell is a 3. Delete the 2 from here, and now look at this simple Sudoku rules rather than killer Sudoku rules. We have a 2 here, a 2 here, therefore we need to put a 2 in column 1. Obviously it can't go in the 12 cage, so the 2 would have to go here. Now I'm scanning across using Sudoku rules again here, so I'm seeing that I would have to put a 2 in one of these two positions. And can we make more progress? We can do a little bit more actually with this 2, because now there's very limited, certainly if we look at this top 3x3 cage, we obviously haven't got a 2 in either of these positions. We haven't got a 2 in any of these 3 positions in column 5. What's more, there can't be a 2 in this 10 cage, because if there was, the other number would be an 8, and that would be a problem for this and a problem for this. So there's going to be a 2 in one of these two positions. Now that means there's going to be a 2 in one of these 3 positions in this 3x3 box, but I can't quite see where that needs to go yet. Now, what more can we do? The other thing I would start to think about now is some of the geometry of the grid. Let's look at the central 3x3 box here. We have a 21 cage and a 15 cage already entirely contained within this 3x3 box. Now 21 plus 15 is 36. And we know that every 3x3 box will add to 45 because it will contain the numbers 1 to 9 exactly once each. If you add the numbers 1 to 9, you get 45. So these 3 numbers here, the ones that aren't in the cages, are going to have to sum to 9, which obviously means that there can't be a 9 on this diagonal. I'm just wondering if we can use that. There can't be an 8 either. I'm sure we're going to be able to use that fact somehow in a minute. Now, how can we do that? Okay. Let's look at this top 3x3 box now. We have a 19 cage and a 2 cage, or a 2 cell within this 3x3 box. They sum to 21. That means there are 3 digits here that need to sum to 24 in order to ensure the cage adds to 45. Now, if 3 digits sum to 24, they have to be 7, 8 and 9. Now, let's see where we can place a 9 in this 3x3 box. We can't put one here because of this 9, and we can't put one here because of this 9. Therefore, this cell must contain a 9. That means this cell, by simple Sudoku rules, contains a 9. Okay, and now we can look, if we look at where we can place a 9 in this 3x3 box, you can see it has to be in one of these 3 positions. Can it be here? Well, no, it can't, because if this was a 9, this would be a 1, and we know there's a 1 in one of these 2 positions in row 4. So the 9 is not in this position. It can't be in this position because of this 9 here. Therefore, it's going to have to be in that position there. Okay, and that's interesting because that means that the 9 in the central 3x3 box has to be in this 21 cage. It has to be either here or here. Right, okay. Oh, this is beautiful. Okay, and this is why some of these hand-created killer Sudokus have beautiful logic in them. So let's have a look at this 21 cage now, where we forced a 9 into it. We know that the other 2 cells in this 21 cage are going to sum to 12. How can you make 12 in 2 digits? Well, if you've already used a 9, you can't use 9 and 3 again. So you could have 4 and 8, or you could have 5 and 7. And ordinarily, that wouldn't be interesting. But look what we have down here. We have a 5 and an 8 in column 4 already. Therefore, whichever version of 12 we're going to have, to complete this 21 cage, it's either going to contain a 5 and a 7 or a 4 and an 8. But whichever version it contains, the 5 or the 8 will have to be in this cell here. I hope that's clear from what I'm saying there. We know that we know this 21 cage is going to contain either a 5 or an 8 somewhere, but neither of the 5 nor the 8 could ever appear in column 4. Therefore, this cell actually can't be a 9. This has to be a 9. I can cross out this 9. This will have to be a 5 or an 8. Therefore, this cell will have to be a 4 or a 7. And that now allows us to place a 9 in this 3x3 box. There's only one place it can now go, and that's in here. And now I think we've done all the 9s. We've done all the 9s now. Okay. Where would I look now? I'd probably have a quick look down at this box here, because we have so many digits already given. We have a 12 and a 13 cage, that's 25. Plus 2 is 27, plus 9 is 36. So I know these two cells here have got to sum up to 9. And can I use that fact? I don't think I can actually. No, I'm not seeing how to use that. I can see this 12 cage is quite restricted. I can't quite, again, I can't see it's going to be 4 or 8 or 5 or 7, but either way round, I can't quite see how to use that to make further progress. I suppose I can label these two cells. These two cells are 7 and 8 in some order. Let's write that in. Oh wow. Hang on a minute. Let's just... Okay. This is more beautiful logic. Let's take a look at this 10 cage now and ask ourselves, how could it be filled? Well, it can't be 1 and 9 because we have a 9 here and a 9 here, so for lots of reasons this 10 cage isn't a 1 and a 9. It can't be 2 or 8 because we already have an 8 somewhere in this 3x3 box. It could be 3 or 7, and it can't be 4 or 6 because of this 6 here. So this 10 cage is 3, 7 in some order, which means that this square must contain 4 and this square must contain an 8. Now let's look at this sort of this very interesting configuration we have in rows 2 and rows 3 regarding 7s and 8s. You can see we have a 7 in one of these two positions and we have a 7 in one of these two positions. Now that means that the 7s in this cage here must be in the top row. You can't have any more 7s in rows 2 and rows 3 because if we try and place a 7, let's say for example we put a 7 here, this would be a 7 and this would have to be a 7, so we'd have two 7s in the same row. So there's going to be a 7 somewhere along here. But we can do exactly the same trick with the 8s. We have an 8 in one of these two positions and we have an 8 in one of these two positions. Therefore there's also going to be an 8 in one of these positions. Now what does that tell us? Well, the first thing it tells us is that this square here has to be a 7 or an 8, because only one of the 7 or the 8 can go into this 11 box. So we can put 1 in for sure, but the other digit will just be the number that takes the total to 11, i.e. it won't be a 7 or an 8. but we know we need to place a 7 and an 8 in this row. Therefore, this square here must contain the other digit. Now, why is that interesting? Well, it's brilliant, because now let's take a look at this 3 by 3 box in total. It contains an 11, it contains a 15, and it contains a 9. So 11 plus 15 is 26, plus 9 is 35. So this square, and this square have to sum up to 10 somehow. So let's ask ourselves the question, could this be an 8? If this was an 8, these two squares would have to sum to 2. They'd both have to equal 1. That's obviously not possible. So in fact, this square must be a 7. Therefore, this 11 is going to contain the 8. It's going to have to be 3 and 8 in some combination. This square is going to be a 1 or a 2, and this square is going to be a 1 or a 2, because we know these two squares have to sum up to 3 in total. Okay, and now this 15, therefore, is 4, 5, and 6. Like that. This 10 cage here, well, it can't be 1 or 9, and it can't be 2 or 8, and it can't be 4 or 6. Therefore, this cage is 3 or 7 in some order. I've been noting here that we have 3s in one of these two positions and 3s in the same columns in one of these two positions. Therefore, we can use this trick again. There can't be any more 3s in columns 7 or 8. Therefore, in this box down here, the 3s are going to be pushed over onto this side of the grid, into this 18 cage in one of these two positions like that. Okay. What more can we say here? Okay, we can make a bit more progress, I think, using the 2s now, because we've completed this. So let's have a look at where we can place a 2 in the central box. There can't be a 2 here or here because of these 2s that we've identified. And look, we have a 2 over here as well, so there can't be a 2 here, here, or here. So there is a 2 in one of these two positions. I don't know which way round it is yet, but that means that the 2 up here has to be over on this side, like that, which means that this is a 1 or a 6, and this is a 1 or a 6. We can remove the 2 from this position here. Okay, what more can we say now? If we look at row 4, we know we still have to place a 2, a 5, and a 6 into one of these positions. Now, feels like we should be able to say something useful on the back of that. Certainly we can see this square would have to be a 5 or a 6. This would have to be 2 or 5. There's already a 6 up here. And I don't quite see how to restrict that square yet. Ah, yes, we can make a bit more progress. Let's focus harder on these 2s. If the 2 was in this 15 cage here, then these two cells would have to sum up to 13. Now 4 and 9 isn't possible because we would have a 9 in this 3 by 3 box, and 5 and 8 isn't possible because of this 8 here, so these two would have to be 6 and 7. But look, we already have a 6 and a 7 in column 6 here, so this cell could never be filled. Therefore this cannot be a 2, this has to be a 2. That means this is not a 2, and we have an interesting triple now looking down this column. We have a 4, 5, 6, 4, 5, 6, 5, 6 combination. So that we know this cannot be a 4. And we've still got 1, 2, 3 and 8 to place in this column somewhere. Let's cross out this 2 here. This 15 cage feels to me like it must be very, very restricted now. Well, yes it is. I mean, where are we going to put a 7 in this central 3 by 3 box now? We know that these 3 cells here from the work we did earlier sum to 9. So we know that none of these 3 cells could be a 7. So the 7 is in this 15 cage somewhere. Well, and there's a 7 here. So in fact, it must be in this position. Which means that these 2 cells here have to sum up to 8. Now they can't be 1 and 7 because of the 7 we already have here, and they can't be 2 and 6 because of this 6. So these 2 cells are 3 and 5 in some order, and we have a 3 here. So it must be this way around, 3 and 5 like that. Okay, which means these 2 cells are 1 and 6 in some order. Let's write that in. Feels like these 2 cells are quite restricted now. We know they have to sum to 10. We know it can't be 1, 9, and it can't be 3, 7. So this either has to be 2 and 8, in which case it would have to be this way round, or 4 and 6. Can't see how we can rule out 4 or 6 here, or 6 here. Let's just check the arithmetic on this bottom 3 by 3 box now. We have an 18 and a 9, which is 27. So we know that these 3 cells here must sum to 18, which means we can rule out this 2. So if this was a 2, these 2 cells would have to sum to 16, which would be a problem because we already have a 9 in the cage, and the only way of making 16 in 2 digits is with a 7 and a 9 combination. So this is not a 2, and therefore this is not an 8. So this is 4, 6 actually, which might be helpful at some point, but maybe not immediately. So we still need to place 1, 4, 6 and 8 in row 6. This square therefore has to be a 6 or an 8. And well, this square can't contain a 4 because of the 4 triple that we've got here. So in fact there's only one square left that can contain a 4 in row 6, and it's this one. This has to be 4, and this has to be 6. Now that nearly feels helpful. So if this is a 6, and we said that these have to add up to 18, so these 2 squares now are summing to 12. Now is there anything that we can rule out there? There's obviously 3 and 9 isn't possible. 4 and 8 is possible if it was this way round. And 5 and 7 is possible, I think, only if it's this way round, like that. So it feels like I should be able to make a bit more of a deduction from that fact, but I'm not quite seeing how to do it. And we can see we need a 1, a 6 and an 8 in this column here. There's already a 6 in column 9, so this square is quite restricted. It's a 1 or an 8. And in general it feels to me like this box is quite restricted too. Let's in fact just give this box a little bit of thought. We know these two squares have to sum up to 9 because we already have 9 plus 12 is 21, plus 13 is 34, plus 2 is 36. And we know the whole 3 by 3 box will add up to 45. So these two squares are definitely add up to 9. Now we can't have 2 and 7 here. We could theoretically, I think, have 1 and 8. Can't see why that would be ruled out yet. Let's just put that in as a possibility. We could also have 3 and 6, but only this way round because of the 6 here and the 3 here. And what's the other alternative? I suppose 4 and 5 would also be possible, wouldn't it? So let's complete the picture. 4 and 5. But quite clearly neither of these cells can be a 7. So we have to ask ourselves, where can the 7 go here? And what would the implication of that be? Well, one possibility would be in the 12 cage here, in which case it would have to go this way round. Obviously the 12 could also be 4 and 8, so like that. Now could the 7 go into this 13 cage? If there was a 7 in this cage, that would have lots of implications. Firstly, the other two digits would have to add up to 6, but they couldn't be 2 and 4. So this 13 cage, one alternative would be the 13 is equal to a 1, a 5 and a 7. So if the 13 does contain a 7, it will have to be of the variety 1, 5 and 7. I think that is still possible, actually, looking at the grid at the moment. This would then have to be a 3, and this would be a 6, and this could still be 4 and 8. Something else to note is that we have a 6 in one of these two positions and a 6 in one of these three positions. Now again, we can use the same trick we've been using to say that there cannot be any more 6's in this box in rows 2 or 3. Because if there's a 6 here, for example, this will be a 6 and there'll be nowhere to place a 6 in one of these three positions. So the 6 in the 19 cage is in one of those two positions. We can see, because there can't be a 3 in either of these positions, and there is a 3 here, we know that the 3 in this 3 by 3 box will be in one of these three positions here. And therefore the 3 in this 3 by 3 box will have to be in one of two positions there or there. And now we can use quite an advanced trick by noticing that we have no idea where a 1 goes in this 3x3 box, except that it doesn't go in either of these positions. So we know it's in column 2 or column 3. And the work we did earlier indicated that there is a 1 in one of these two positions, in column 2 and column 3 in this 3x3 box. Therefore, we know that the 1 in the top 3x3 box is going to be forced over onto this side again. And therefore we're able, through this elimination process with the 3's and with the 1's, to actually lock in this 1-3 double in this position here, which is incredibly beautiful, and may actually help us to now crack the puzzle. So we now know that these 3 cells here are 4, 5 and 6 in some order. We know that the 6 is in the top row, so we can write those possibilities in like that. And look now, if we're careful and look along row 2, we have a 4, 5, a 5, 6 and a 4, 5, 6 triple now in row 2. Therefore this square here cannot contain a 6. This square has to be an 8. So that's going to have to resolve itself that way round. We can now remove the 6 from here. This 8 forces this to be an 8 and this to be a 7, which forces this square here to be a 7, which means that actually in this 12 cage here it is the 4, 8 that we're looking for, not the 5, 7. So we can now remove those two possibilities, and we can remove the 1, 8 possibility from these two cells, having had to add to 9 as well. And the 4, 5 isn't possible, so in fact, because of this 4, so this has to be 3 and this has to be 6. We can eliminate the 6 from here, so the 6 is in fact in this position. This has to be a 3 because we've identified that one of these two squares was a 3, and we now have a 3 over here. And now we need to place a 3 somewhere in this box, but we know from the work we did earlier this is a 1 or a 6. This definitely isn't a 3, and this isn't a 3 either. Therefore the only place left for a 3 is in the bottom, well, in row 9. We'll write in the 1, 5, 7 possibility down here, just for good order. Now the fact that we have an 8 in one of these two positions and an 8 in one of these two positions means there cannot be any more 8s in rows 3 or rows 7 and 8. So this cannot be an 8. If you don't believe me, let's just imagine it was an 8. If this is an 8, this would be an 8, and this would be an 8. So we would break row 7. So this is not an 8, therefore it is a 7, which means that this is a 5. And I think we're starting to finish off the puzzle now. Clearly an 8. This has to now be a 6. And this is a 6. That means this is a 5 over here. This has to be a 6. This is a 6. This is a 1. Well, this is a 6. This 5 here forces this to be a 5, and this to be an 8, this to be an 8, and this to be a 4. Scanning down this column here. I've got to place 1, 2 and 8. But this can only be 1 or 2. This can, the 5 and 7 in row 8 here mean that this can only be a 1 now. Therefore that has to be a 5, and this has to be a 7. This has to be a 1, this has to be a 4, this has to be a 4, and this has to be a 5. Therefore this is a 1, and this is a 4, and this is a 1, and this is a 2. 1s are down here, along with 8s, so that's an 8. This is a 1, this is a 1, this is a 2, this is a 1, this is a 3, this is a 3, and this is a 7. This is a 5, this is a 4, this is a 4, and this is a 5. You can see, hopefully, that all the rows and columns are working out, so that gives us some comfort that we are honing in on the correct solution. This has to be a 5. And we're still looking to place a 2 and a 4 down column 8 here. Well, that has to be a 2 now. This is going to be a 4, and this is going to be a 2. This has to be a 1, and this has to be an 8. And hopefully, if everything's worked out correctly, this should be an 8. And look, it looks like it's correct. And there we go. And this is an example of how handcrafted puzzles, this one by Serkan Yürekli, who, as I say, is an absolute masterful puzzle setter, can be beautiful. So I hope that was a useful run through. I hope it's interesting. I hope I did it at the right speed today. I think there were a couple of comments that I went a bit quickly on the Killer Sudoku that I did over the weekend, but something a bit different. And yeah, look forward to seeing you next time on Cracking the Cryptic.